it will be important for us now to examine in this relationship when we say y equals inverse sine of x, what do the values of x and y mean? Well, going back, remember, we said that if we were able to limit our domains like this to make them one-to-one, then we can find an inverse function. So if we go through the process right here and we say, all right, let's deal with our original function f of x equals sine of x, except that we limit sine of x to the specific interval from negative pi over 2 to positive pi over 2. And if you recall finding inverse functions, the process went like this. We replaced f of x with y. And of course, everywhere we saw x, we replaced x, we carried that through with our calculation. So here's what's going to happen. So if we switch the x's and the y's, x is going to be equal to the sine of y, only this time y will be enclosed on the interval from negative pi over 2 to positive pi over 2. And we observe that that means that y now must be an angle somewhere between negative pi over 2 and positive pi over 2 radians. And so isolating y in our equation, we write that y is equal to the inverse sine of x. And we know that y is limited to being between negative pi over 2 and positive pi over 2. Of course, what does that mean about x? Well, in the original function, f of x equals sine of x, we might note that the range of this function was negative 1 to positive 1. And so changing the place of x and y means that x is from negative 1 to positive 1. Now, what does that mean? Well, a good way to start thinking about this inverse function, f inverse of x, which is our inverse sine of x, a good place to start is to pick a particular value and check it out. What does it mean? In this function, now it's not necessary to write these two items because it's assumed that when we write inverse sine of x, that's exactly what we mean. But in order to help us visualize it, let's pick an original situation. Let's say that I told you to find the sine of the angle pi over 6. Well, you know that when we take the sine of the angle pi over 6, what we mean is the ratio of the opposite side to the hypotenuse side of a right triangle containing that pi over 6 angle. So if we look over here in our green triangle right here, and it might contain the angle pi over 6, we'll note that the sine is the ratio of opposite to hypotenuse 1/2. So what does the inverse sine do? Well, the inverse sine reverses that relationship. It says then that the angle pi over 6 is the result of taking the inverse sine of the ratio 1/2. In other words, we're finding the angle that goes with the particular ratio when we use the inverse sine. So when we write this relationship y is equal to the inverse sine of the number 1/2, or radical 3 over 2, you pick one, we mean that x, that's our ratio from the right triangle that corresponds to the value, and of course y has to be the angle. So that's x is the ratio, y is the angle that goes with that right triangle. Now I drew another one down here in purple just so that we could see it. What happens with this relationship? Well, let's take our y values then. Our y values are the angles, so the y values are limited to being angles whose values range from negative pi over 2, which is, if you recall, in standard position angle that starts on the x-axis and rotates in the clockwise direction 90 degrees, pi over 2 to a right angle, or as high as pi over 2. So we might be interested in finding out, well, what would this relationship be? Well, let's pick an angle that we know down here. Let's go with negative pi over 3. What would we say about that angle? Well, we know we're in the third quadrant, and if I took the sine of the angle pi over 3, I know that I would get the result that the sine of that angle pi over 3 would be of negative pi over 3. Let me put this in the correct quadrant, pardon me. Of negative pi over 3, that would give me negative root 3 over 2. Angles that terminate in the second quadrant or in the fourth quadrant, have a negative value for sine. So what we would have to say then is that negative pi over 3 would be the result of taking the inverse sine of the ratio negative root 3 over 2. And so keeping these positions in mind is really, really helpful when we start evaluating these inverse trigonometric functions and determining what they mean. More to come.